Hi, let's continue our discussion of quadratic functions by reviewing, first of all, that we can find the vertex of a quadratic function that is in standard form by looking at the horizontal and vertical shifting components. So we see, for example, if f of x is negative 1/2 x minus 1 quantity squared plus 2, you would shift right 1 and up 2. And even though the parabola is reflected about the x-axis before it's moved up 2, that the vertex would indeed be the ordered pair 1, 2. And so in our last video, we said that in general, if you had y equals a times x minus h quantity squared plus k, that your vertex would indeed be the ordered pair hk. Now, take a look at the parabola to my right, which is f of x equals 2x squared minus 4x minus 1. I want you to notice between the two forms that f of x equals ax squared plus bx plus c is referred to as general form, but it's simply, if you will, the multiplied out version of standard form. So if I were to take standard form and think of multiplying x minus h times x minus h and then collecting all the like terms, etc., basically the coefficient a is going to be the leading coefficient overall. And when you collect like terms, you get this general form anyway. So what's consistent about these two is that the leading coefficient, the number a, is the same in each form and indeed controls which way the parabola opens. Okay, so for f of x equals 2x squared minus 4x minus 1, your parabola is opening upward because the leading coefficient is positive. Okay, now just to review some terminology, and I'll do it on the graph in general form, is this guy's I've already graphed for you. It has a vertex of 1, negative 3. I'll show you how we find that in a moment, but let's just review. This parabola opens upward, so therefore it has a smallest y-coordinate, which is referred to as the minimum value. Value means number, so the value is not an ordered pair. The vertex is an ordered pair, and the minimum value in this case is the y-coordinate of the vertex. Okay. Likewise, if I wanted to read the range from bottom to top, it's pretty straightforward once you identify the vertex and the direction in which the parabola opens. So the range would be minus 3 included to infinity. And then if I wanted the axis of symmetry, of course, it's always x equals the x-coordinate of your vertex as referenced here. Okay? So let's say I take this parabola more specifically. How do we get general form to give us the vertex? I'm going to demonstrate a technique that we reviewed when we looked at equations of circles, which is completing the square. And let's take this tactic. I'm going to group the x terms together. So I'll have 2x squared and minus 4x grouped together. Since we prefer to complete the square with the leading coefficient on the square term as 1, I'm going to factor out the 2, but only from the guys that I have grouped. So I'll have 2 times the quantity x squared minus 2x, and then I still have minus 1 off to the side here. If you recall, completing the square means that we figure out what number we need to add to our binomial to make it a trinomial that factors as a perfect square. And the technique was this. We'll take half the middle coefficient, which that gives us basically negative 1, and negative 1 squared is what we put here. And that's just 1. Now with circles, we did the technique adding to both sides because we wanted the radius to be on one side. With this guy, I want to leave it f of x equals, so whatever I add or to this internal part of the expression, I'm going to make sure I balance my equation. So I want you to notice what really happens. If I distribute the 2x squared, or excuse me, the 2 through the parentheses, I would ultimately get to 2 times 1, which means essentially I have added the number 2 to this side of the equation. So whatever I've done, I want to cancel it out. So in this case, I'm going to subtract that value 2, so that if I were to clean everything back up, I'd be where I needed to be. Okay, and once I'm here, I would have f of x equals 2, x squared minus 2x plus 1. We have created this so that it will factor as x minus 1 quantity squared, and then taking the negative 1 I already had, subtracting the 2 that I really added to make the completing the square work, I have a minus 3 on the end, which means the vertex of our parabola using standard form technique is indeed 1, negative 3. Okay? So the question I have for you is, how do you do this in general if you want to generalize this process? I want you to think about this on your own, but I'll get you started. And this is worked out actually in your ebook. If we were to take the same concept, which is group the x terms, factor out any leading coefficient, leave the constant by itself, figure out what we needed to do to complete the square, which is half of the number b over a quantity squared. So that would be b over 2a quantity squared plus the number c. And then I want to remember what I've really done is added a times the quantity b over 2a squared, so I'll subtract that. Okay, and I'm not overly worried about cleaning a lot of stuff up just yet. And so basically, if you do the algebra you need to do here, we've created this to factor as a times the quantity x plus b over 2a quantity squared plus what I'm going to say is the stuff on the end that collects. Okay? Because here's what's really nice and neat about this. If you can find the x-coordinate of the vertex, then you could substitute to get the y. So here's your big alert. The x-coordinate of the vertex of this quadratic function must be left b over 2a units, or x equals negative b over 2a. And then what we will do is substitute to find the y-coordinate of the vertex. Okay, so let's wrap this up by trying this one more time. I want you to notice we've found a formula. It's very handy so that you don't have to continually complete the square. So when you look at f of x equals 2x squared minus 4x minus 1, then what we're saying we've discovered is that the x-coordinate of the vertex should be obtained by calculating negative b, which is the middle coefficient, divided by 2 times the leading coefficient. And this gives us basically the value of 1. If we then substitute 1 in for x in the formula, f of x, in other words, we calculate f of 1, Then we have the correct y value of the vertex, just like we hoped we would. So this is a fantastic result. So let's circle this. This is one of those happy results. Okay? All right, that's all for this one.